So what is direction of current? Direction of current is opposite to the direction of the direction of the current is basically opposite to the direction of the electrons. So if all the electrons are moving on the right hand side, then the direction of the current is basically left hand side. If the electrons are moving on the left hand side, then the direction of the current is on the right hand side. You understand this?
Yeah, understood.
Yeah. So if I have to define current, what is current basically? Current is the flow of electrons per unit time. Current is constituted, like how is current formed? Current is formed with the flow of electrons. Like if the electrons are flowing, they will constitute current. If I have to find the value of current, that how much current is flowing. So how can I find? I can have the symbol for current is I. So I can say I is equals to Q upon T. What is the meaning of I is equals to Q upon T? That if you have to find that how much current is flowing, then you can say Q upon T. That the amount of charge divided by time, that constitutes the current. That how much charge is being flowed. Like you have 1 coulombs of charge, you have 5 coulombs of charge, 6 coulombs of charge, and in how much time is it passing at one particular point. Okay, that is known as electric current. So what is the definition of current? The amount of current passing charge, the amount of charge passing per unit time is known as electric current.
Okay.
Now, how do we calculate the charge? Basically, always remember that one electron has a charge of 1.6 into 10 to the power minus, 10 to the power minus 19 coulombs. This is the charge on one electron. One electron has a very small charge. See, it is very, very, very small, minus 19 coulombs. So one electron, the charge is 1.6 into 10 to the power minus 19 coulombs. So this is the charge on one electron. So how will you find, like if I say that find the current by 4 electrons in 1 second. So 4 electrons in 1 second. So current is equals to Q upon T. If there are 4 electrons, so how much charge is there? You have 4 electrons. On one electron, how much charge is there?
Yeah, one electron, it's 1.6 into 10 to the power minus 19 coulombs.
So how much charge is there on 4 electrons?
Could be like into 4, right? So
4 into 1.6 into 10 to the power minus 19 coulombs. This will be the charge. What will be the time? I'm saying 2 seconds. So 2 seconds is this. So you can divide it. 3.2 into 10 to the power minus 19 ampere. The unit of current is ampere. Okay. So if 4 electrons are moving in 2 seconds, then how much current will they produce? They will produce a current of 3.2 into 10 to the power minus 19 ampere. Hope that this is clear to you.
yeah, it's clear.
Okay. Now you have a circuit diagram. Now what is a circuit diagram? See, basically if you have, this is a bulb. Always remember that a battery, now this is a battery has two terminals, a positive terminal and a negative terminal, and the current flows from the positive terminal to the negative terminal. So the current will start flowing from here, it will move all the way and now it will enter back into the battery from the negative terminal. Okay, this is a bulb. This is a key. The meaning of key is basically switch. Like we on and off a switch, we put on the switch and we put off the switch. So that is a key. And then this is an ammeter. Fine, this is an ammeter. We have a bulb, we have a key, and then we have an ammeter. Okay, and this is a battery. You understand this?
Yeah, understood.
Circuit diagram. Okay, now I'll give you one question. You have a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Okay, you have that there is a current of 0.5 ampere being drawn by a filament and the time is given to you. So current is given to you, time is given to you. You have to find the electric charge. Will you be able to do this question, Zoha?
Yeah, I'll be able to do it
Yeah, please remember units. Units is very important. All the units must be in the SI format.
with SI.
Yeah.
Okay, so the the charge is 0.05 coulombs.
No. Oh, you're telling me the charge. Wait. The current is 0.5 amperes. The time is 10 minutes. Okay. So I told you to take in SI units. What is the SI unit for time?
It's meter per second.
Time, Zoha.
Oh, oh yeah, we have to take it in seconds, right?
Yeah.
Seconds.
Please redo it.
Seconds. So now I'm getting Q as 1200.
Let's check. So time is 10 minutes. So 10 minutes you'll convert into seconds. You have 10
Yeah, it
into
will become
60 seconds.
600.
You have 600 seconds.
Yeah,
So then
600.
you have, what is the formula? You have current. I is equals to
I
Q
is equal to
upon
Q
T.
by T. Yeah.
Yeah. So
Yeah,
over here, I is 0.5 is equals to Q upon T is 600. So
600. Yeah.
Q you will get as 0.5 into 600. Okay. Now a 0, 0 and 0 will be cut. You'll have 300 coulombs. Fine.
Okay. Yeah.
Okay. Now you have the next question. First is define the unit of current. This question I taught you previously as well, and now also I've told you a little bit. I hope you'll be able to do it. Next, it is calculate the number of electrons constituting 1 coulomb of charge. Okay.
Okay.
Zoha, have you done?
Just give me 1 second. I'm doing the second one.
Yeah, okay.
Okay, I got the answer.
Okay, so you have the first question is define the unit of current. So tell me the answer for this.
Okay, so 1 unit of current it's defined as 1 ampere. Like 1 ampere, it measures the flow of current in the circuit.
But how will you define the unit? Tell me how will you define the unit of current? See, when you have to define the unit of something, what do you do? Like you have I is equals to Q upon T, right? So first you write the formula. So unit of current. So what is the formula for current? The formula for current is Q by T. So the unit of current is ampere. The unit of Q is coulombs and time is seconds. So 1 ampere is defined as the amount of charge that passes, or you can say, can be defined as like when, wait, let's change the language of the answer. We can say when 1 coulomb of charge passes in 1 second, it constitutes 1 ampere of current. Got it?
Yeah, I got it.
Please remember this. Then the second question, how have you done?
It's like I'm not sure if my answer is correct. Like,
No problem. Let's discuss it. For the second one, you have calculate the number of electrons constituting 1 coulomb of charge. So it is given, what is the charge? Q is 1 coulomb. Okay. What do
yeah,
you have to calculate? You have to calculate the number of electrons. Now I told you one thing, that 1 electron has how many charge? Has how much of charge? 1.6
yeah,
into 10 to the
1.6
power
into 10
minus
to the power
19
minus
coulombs.
19. Yeah.
Now just use the unitary method. So if like, just reverse it. You can say 1.6 into 10 to the power minus 19 coulomb gives is present in 1 electron. So 1 coulomb is present in how many electrons? 1 upon 1.6 into 10 to the power minus 19. Right. So 1 coulomb is present in 10 by 16 into 10 power 19. It's 6.25 into 10 power 9. Okay, so these many electrons are required for 1 coulomb of charge.
Okay.
6.25 into 10 power 9, 10 power 19 electrons will form 1 coulomb of charge. Clear?
Yeah, it's clear.
Okay. Now, okay, we have the next topic now. But before starting with the next topic, Zoha, I have your school question papers, like your exam question papers. We also have to discuss that thing.
Yeah, okay.
Yes, let's start with that discussion. We have completed one of the topic of this chapter. We'll keep it up till here only. I hope that this topic was clear to you. Let's have a quick revision. So first of all, I taught you what is electric current. So electric current is basically uh,
Yeah, it's the flow of electrons.
How is an electric current constituted? Electric current is constituted with the help of flow of the electrons, right? They constitute an electric current. Now, electrons are basically, what is the direction of the electric current? Direction of electric current, we study that it is opposite to that of the electron. Like if the electrons are moving on the right hand side, then the current is flowing to the left hand side. Then we studied the formula for electric current, which is I is equals to Q by T. Then I also told you one important formula, which is one electron constitutes how much of the current? It constitutes 1.6 into 10 power minus 19 coulombs. Then we studied what is a circuit diagram. So circuit diagram is a diagram which consists of a bulb, a battery, a key, and an ammeter. Okay, battery, we know that the current starts from the positive terminal and enters back into the battery through the negative terminal. Key is basically defined as a switch, like the on and off switch. Then we have the bulb and then we have the amp. Right. When we practice the question, you need to remember that whenever you are solving the question, all the units must be in the SI. All the values must be in the SI. When we practice some more questions, this question is very important. Define the unit of current. Why is this important? Because this type of questions are also formed in the other topics, like define 1 volt, define 1 ampere, define unit of current, define unit of resistance. So for that, such type of questions, what you have to do, you just have to write the formula, and in the formula you just have to like put the value for each of the values as 1. Like when 1 coulomb of charge passes in 1 second, it constitutes 1 ampere of the current, right?
Yeah.
Now for your school question paper, just give me 1 minute. We discussed the physics part. Okay, so the first question was for a real object. Do you have your question paper with you?
Yeah, I have my question paper with me.
Okay. So the first question was for a real object, a convex mirror always forms an image which is.
It's virtual and erect.
Okay. Yeah, that's correct. For a convex mirror. So convex mirror is basically forming a virtual and an erect. Good.
Yeah,
So
according to
power
their
for
diagrams.
convex lens or focal length 50. Okay, what is the formula for power?
The formula of power is
Yeah.
no wait, I remember this one because I did this one quickly.
No problem. Think about it. What you did in the answer?
Give me 1 second. I remember the formula because I did this answer. I struggled a lot with this one.
No problem. See, the formula for power is 1 upon focal length.
Yeah, 1 upon focal length.
Okay. But you use 1 upon focal length when focal length is in meters.
Yeah, and focal length is in meters. That's why you have to convert it into that.
So you can say 10 by focal length.
Yeah, 10 by focal length.
Okay. So you have 10 by 50. So answer comes out to be power is 1 by 5. Why have you written 2? 0.2 is not even the answer.
It's not the answer.
No.
Then don't you have to convert that 50 centimeters into meters? And then you divide it.
You have focal length is 50 centimeter. Okay. So you can say focal length is 50 by 100 meter. Right. You have 1 by 2 meter. Now power is equals to 1 by focal length. So power is equals to 1 by 2 means 2 reactors. Okay.
Okay, yeah.
Now tell me why have you written positive 2 and not negative 2?
The reason we take positive 2 is because it is a convex lens.
Okay, good.
That's how we have to take it as a positive. I wrote negative first, but then I remember it's a convex lens. So I wrote the positive.
So for like if this is a convex mirror, so yeah, I hope that you know this. For a convex lens, we have positive. For a concave lens, we have negative. So given a point source of light, which of the following can produce a parallel beam of light? So given a point source, so this is like a point source of light. Okay, which of the following can produce a parallel source of light? So parallel source by which, like first of all, from a point source, we will have something like this. Now, if I have a concave lens, so concave lens is something like this. It won't produce parallel lines.
Yeah, it won't. Because it's a lens. So
Concave mirror. Okay, what about concave mirror? This is a concave mirror. What does a concave mirror do?
right, the concave mirror, it converges the light rays.
Okay, so why is it not forming parallel? Why the answer is not concave mirror?
The reason it's not like concave or convex mirror is because the light rays, like, okay, fine, when it bounces towards the mirror, it's parallel, but like when it bounces back, it's not parallel. Like instead, it converges into the focus. But then for a plane mirror, when the light rays bounce, it bounces back in a parallel beam. That's why I wrote that answer.
No, Zoha, your this answer is wrong. It should be concave mirror. The answer should be concave. Okay, wait, I'll explain. See, what does a concave mirror do? What is a concave mirror? Look here. If concave mirror, this is a concave mirror, right? So this is a point source of light. What is the function of what kind of rays will a concave mirror produce? Something like this.
Yeah, it will produce something like this.
Yeah. Is this much clear?
Yeah.
Okay, now tell me, what does a concave mirror do? It converges.
Yeah, it
Okay,
converges
concave
the
mirror
light.
will converge. Converge means to bring closer together. So, like this one will pass exactly like this. All of these, if this was going like this, okay, initial path was this. Now it will be converged. It will be brought closer together. It was this line was going like this. Now it will be converged. This line was going like this. Now it will be converged. Again, this line was going like this. It will be converged. So you get a parallel source of light. You get parallel beams.
Oh.
Your answer is wrong. See, the answer that you've marked is plane mirror.
Yeah.
If you look at a plane mirror, this is basically a plane. If any kind of light, does plane mirror converges or diverges anything? Does it? Or it only lets the beam of light pass through it?
It only allows the beam of light pass.
Exactly. So if you have any light ray coming like this, it will keep on passing like this only. If you have any ray passing like this, it will keep on passing like this only.
But
It
the
will
light
neither
ray
converge
doesn't
nor
bounce back.
diverge.
The light ray doesn't bounce back on a plane mirror. It just passes through.
Okay, so if you're talking about, okay, bouncing back, let's consider that this is a plane mirror. You have this parallel point source of light. Now it is bouncing back. Okay, now tell me, now it will bounce back. It will bounce back like this.
Yeah, it will bounce back like that.
Yeah, so it is still not forming a parallel beam of light. Fine, it is still not forming a parallel beam.
Yeah, it's not forming a parallel beam.
Yeah, the answer should be
Logic
concave
is
mirror.
it's a concave mirror.
Yeah. Then you have question 4. Sodium carbonate. No, that's chemistry. Then again chemistry.
The rest of them are chemistry or biology. If you go to question number
Okay, you go to question
number
number
13.
16.
Question number 13 is a physics one.
Question 13 is, for observing traffic at our backs, we prefer to use a convex mirror. Okay, what does a convex mirror do?
The convex mirror, it diverges the rays, and like the reason we use it as like a car mirror is because it provides a wider range of vision, so we can see
Yeah.
everything on the road.
So
So
assertion is true. It's
yeah,
correct. Okay,
yeah,
what about the reason? The reason
yeah.
is a convex mirror has a much larger field of view than a plane mirror. Okay, this is also true.
Is also true.
So both A and R are true and R is the correct. Okay, so this question is correct. Question 13. Good. The next is question 16 you have.
Yeah, question 16. I did the second one. What is meant by power of accommodation of the eye?
Yeah, tell me. We did study
Like,
part of competition.
so power of accommodation is like the capacity of the eye to focus, like focus on an object. That is the power of accommodation.
Okay, you could have also mentioned some examples, like when
Yeah,
we are seeing at far distant objects.
yeah,
And
I did mention that. It's like when we see the objects from a distance, then the focal length is larger. But when we see it from near, it is smaller. I wrote that part too.
very good, that's correct. Next is,
Yeah, that's the rest of them.
okay, that's it. Nothing else. Nothing from section D. You have question 23 as well.
Yeah, 23 and 26. Those are 5 mark questions.
You have question 23. Did you attempt question 23?
Yeah, I attempted all the questions in the paper.
So question 23 is the refraction of light on going from one medium to another takes place according to two laws. Okay, the laws is given. Then there are questions. In which condition angle of incidence is greater than the angle of refraction?
The angle of incidence is greater than the angle of refraction. Okay, so for this answer, like I didn't really know the answer, so I wrote a completely wrong answer just to fill it in. So I don't know the answer for this.
Okay, what about the next?
Oh yeah, what kind of mirror is used by the dentist? It is it's a concave mirror, right?
Okay, yeah. Why do we use a concave mirror? Because a
It's
concave mirror basically produces an enlarged image.
in
And
my
when a
enlarged
dentist is
version.
looking at the, like, a dentist wants to have an enlarged view of our whatever he's looking at, the teeth or the gums.
Yeah, gums we have to use a the
Yes.
concave.
Next, you have refractive. You have to attempt either C or D. So you attempted D1. Show angle
Yeah,
of
D1.
deviation in a glass prism. I hope you must have drawn the diagram.
Yeah, I drew the triangle, and then you have to like when you draw the rays like this, you have to extend the angle of incidence and the angle of angle of emergence. No,
Okay, now first see 24th question. I'm sorry, 23rd question. First question, I'll not explain it here because
yeah,
it's basically related to the concept of refraction and we didn't revise refraction in the class. We only studied till reflection in light. Yeah, so we'll do one thing. We'll have a class for refraction as well. I guess this chapter must be there in your final examinations as well. So when we
yeah, it is.
revise the chapter, then I'll discuss it with the question because it's of no use when I haven't like when we are not clear with the topics, when we are not clear with the concepts. There's no point of discussing the question.
Yeah,
Okay, question 26 is state the main causes of a person developing nearsightedness with help of a diagram. Okay, what are the two causes? We did study them.
yeah, we did. So nearsightedness is like I wrote that it is myopia. It's when a person can see what is near but they cannot see what is far. And like the causes is because of the is like the elongation of the eyeball or the excessive curvature of the lens. And myopia can be I basically wrote all the information. Like myopia can be treated by using a concave lens as it diverges the light rays, and then the eye lens it converges it again, and then the image is formed on the retina. And then I drew all of the diagrams, the normal eye, the far point of the myopic eye, and the correction for myopic eye. I drew all the diagrams.
Okay, very good, Zoha. So I hope that your paper went well. Okay, what about chemistry and biology? Did you attempt those sections well?
Yeah, I also attempted the sections. Like
So
compared to the other exams.
have you received your answer sheets?
Yeah, I have.
How much marks did you obtain?
The marks that I think I obtained are maybe like above 40, inshallah. Like because I did make some mistakes here and there.
Okay, but that's good. Like a good score. Very nice. Um, Now from the next test onwards, I hope that you don't repeat those silly mistakes. Okay,
Yeah,
you knew all the concepts. You were thorough with the concepts. I knew. In the class also we've practiced a lot of things. Good. Now, okay. So now Zoha, from the next class onwards, we'll be starting with the next topic, which is I have to check it. It's voltage related something.
voltage.
gets electric potential and potential difference. Fine. So in the next class onwards, we'll be starting with electric potential and potential difference. Till then, please practice all the theoretical part that I've taught you. Do you have your NCERT textbook? So it's important that whatever topic I'm teaching you, like today I taught you electric current and circuits. So it's important that after the class, before